The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody. It's Lisa Travers from Alliance Corporation. Thank you for joining us today for our webinar on microwave antennas with CommScope. Just a couple of housekeeping questions or facts. Most of the time throughout the webinar, all of you will be on mute. It just eliminates interference. So if you have a question you'd like to ask Jackie, our presenter, just type it into the questions or chat console on the GoToWebinar pane. And I will hold them most of the time till the end of the webinar, and then I'll read them out to Jackie. And I think that's about it, so I'm going to hand things over to Boyd Cowan from Alliance, who's going to do a quick introduction to our speakers today.
Okay, thank you very much, Lisa, and thanks to everybody on the line and on the screen for joining us for the webinar today. I'm not going to be actually conducting any slides or going through the webinar, but what I would like to do is give a quick introduction to Ray Simon and Jackie Mardos from CommScope. Ray Simon is responsible for channel sales for CommScope in North America, and as most of you probably know, Alliance is CommScope's channel partner in Canada. So while they manufacture the product, Alliance is responsible for reselling it into the Canadian market. And then Jackie Mardos is going to continue through a detailed presentation on the microwave antennas. Jackie is the product line manager for CommScope Microwave antennas and most things microwave. So Jackie will also touch on not only the antennas, but elliptical waveguide, dehydrators, pressurization, and the accessories that go into an entire microwave system. So thanks again for joining us, everybody, and with no further ado, I will turn it over to Ray Simon. Hi, Ray. Ray, are you there?
Thank you, Boyd. Yeah, so I appreciate the opportunity. Boyd?
Yeah, I can hear you, Ray.
Boyd? Okay, Boyd, excellent. Sorry about that. You can hear me okay?
I can hear you fine, Ray. Thank you.
Boyd? Okay, excellent. Thank you. Well, I appreciate everybody's time today. So again, as Boyd mentioned, I'm Ray Simon. I'm the National Channel Manager with CommScope, responsible for supporting Alliance, support Alliance across all of our product lines. And before we jump into the presentation that Jackie's going to be going over on microwave, I just wanted to provide a brief overview on CommScope for folks that might not be familiar with it. So CommScope, we have three major market segments that we serve. The first is broadband, which we serve for our cable TV providers, products such as head-end equipment, outside equipment, and residential solutions, all for the cable TV provider market. Our enterprise market is the products that we have there, and solutions are for our data center, in-building wireless, intelligent building, and campus solutions, all for major Fortune 500, Fortune 1000 companies. And then on the wireless side, we have our outdoor macro sites, everything that you would see on your typical wireless cellular tower. Our DAS, distributed coverage and capacity solutions. Our backhaul solutions that Jackie's going to go over here in just a few minutes, and then also small cell solutions. CommScope is a rather large company, over $3 billion a year in revenue, 11,000 employees. We've got manufacturing facilities, over 20 manufacturing facilities, and we're very global countries, serving over 100 countries. And from an R&D perspective, a lot of the revenue goes back into R&D. You can see here over 2,700 patents and over $100 million going back in annually to our R&D. So taking a look at those three markets, we do have top leadership positions in products in each of those markets. So from a wireless perspective, we're a market leader in microwave antennas, base station antennas, cabling solutions, and DAS. Enterprise, from a structured cabling, we're certainly a market leader there in both fiber and copper. And broadband, we're a leader there in coax and fiber optic cables for both trunk and drop cable solutions. So the mission at CommScope is to enable communication by driving innovation, helping customers adapt to change quickly, and operating with integrity. And so all of these three philosophies certainly hold true for our microwave solution that Jackie will be going over here shortly. So with that, I will turn it over to Jackie Mardos from our product marketing management team for our microwave solutions. Jackie?
Thank you, Ray. And thank you, Boyd and Lisa, for organizing this event. It's a pleasure to be able to speak to our customers in Canada. Hopefully, you will find the material of interest. What I'd like to do today is just do a brief overview of the microwave solutions that we have available, but really spend most of my time talking about Sentinel, or Class 4 antennas. If you have any questions, as Lisa mentioned, please enter it in your chat line. I certainly love to talk microwave, but I promise to leave some time at the end to answer any questions that you might have. As Ray indicated, CommScope is a global company. We have three marketing segments. My segment, the wireless portion, pertains to microwave backhaul. I'm a Legacy Andrew employee, so there are many flashes that I see when I'm traveling through Canada, so thank you. You're very loyal customer base in Canada. And it's because we not only provide the biggest breadth of antenna solutions, but we have not only the product support, but also the excellent partners in alliance to help us support the territory. When we design products in the Microwave Systems group, we don't just design an antenna and then somebody in another group or another state or another country develops or designs the waveguide or the connectors or steel products. We design all of those products to work together. So when we're talking about a microwave antenna, we want to make sure that all of the steel structure, the steel support, has been tested not only for our antenna, but the various types of towers and applications and scenarios that you might see out in the field. With the Alliance team and Ray and his team, we're able to support not just products, but the entire solution for a microwave backhaul. We have 4 primary facilities that manufacture our microwave products. The first is the Reynosa, Mexico plant. It is the only plant that manufactures the large terrestrial microwave or the traditional TMW type antennas. That plant by far is our leading volume plant for the traditional TMW antennas. The Czech Republic, very large plant that not only manufactures the traditional TMW antennas, but also our value line antennas. And just recently, all of our elliptical waveguide products, connectors, accessories, have moved from our Joliet, Illinois facility to our Claremont, North Carolina facility. And again, any one of these facilities, please, if your travel plans allow, we would love to have you visit any one of these plants for a tour to see not only the antennas, but also other products that we manufacture. Okay, so what are the challenges that we're seeing? You know, obviously, if I talk to any one of you, you would probably say capacity. All of us as consumers with our smartphones and smart devices, and throw in a couple of teenagers in each family that loves to download, we see that the demand for capacity is ever increasing. Density, you know, the number of microwave paths that we're seeing that the FCC and the Canadian SRSP are coordinating has quadrupled over the last 3 years. The expectations of us as consumers, we want the quality of service to be high, the best that it can be. We want it faster, better, and cheaper. And overall, how do we reduce the total cost of ownership? Whether you're a carrier, whether you're an operator, you're an installer, you're trying to make sure that you not only provide the best possible system, but reduce the total cost of ownership. So when we looked at these challenges, and we sent out a poll a few years ago and really asked customers what drives their build and design. And basically, these are the 4 categories that just kept coming back up over and over in the responses. And so we took a look as an antenna manufacturer, and we realized that radio OEMs have developed incredible radios. They have increased the features, the bandwidth, the introduction, and now the expansion of ACM in many radios. And we realized that even though the antenna is a passive component, there has to be ways that we can improve that antenna design and help complement these features in the radio. So we took a look at the antennas. I'll introduce our new antenna line, Sentinel, in a few slides. But just as a quick tutorial, I'd like to just go over some of the items in a typical microwave system. So the photo on the top left of your screen is an integrated value line antenna. When I say integrated, I mean the antenna allows for the radio to be directly mounted or fixed to the back of the dish. It eliminates the need for any type of transmission line. The top center photo is our dual pole antenna solution. Capacity, capacity, capacity. Putting up a single pole antenna just doesn't make sense anymore. May not need it today, but I'm sure in a very short time you'll realize, oh, I should have done a dual pole or dual capacity type antenna. The picture on the top right, traditional TMW or terrestrial microwave antennas. These are the granddaddies, the old workhorses that we see everywhere, especially out in open terrain. Typically, these antennas start out at 6 gigahertz and go up to 11. Although we do have higher frequencies available, it seems like the bread and butter or the workhorses work in the 6 and 11 frequency band. The picture at the bottom left, again, another solution that is available from CommScope is outdoor cabinet solutions, pole-mounted cabinet solutions. Anything that can help your enclosure needs, we do have available. The old elliptical waveguide, the granddaddy of transmission line, is the second photo from the left. Elliptical waveguide, has the best performance for a microwave system. As far as attenuation, VSWR, it is the preferred type of transmission line. With elliptical waveguide, you need some type of dehydrator or pressurization equipment, and that is the photo, the second from bottom right. The pressurization equipment through the years have evolved to very small units, very small quiet units from the ones we saw 20 years ago. No more nitrogen tanks, no more bottle tanks. We now have small VCR type footprint units that can be put in any offices or outside plants or shelters. And then from CommScope, rounding off, the ancillary products are your flex, twist, any of your rigid components, all of the plumbing, if you will, that help make that connection solid. Again, all of these products are meant to work together. They're designed and tested to work together. We still put all of our antennas on a test range. And what does that mean? We don't do computer simulations on their performance. We don't assume any radiation pattern envelopes, we actually test our antennas on a test range for a full 360 degrees at vertical to vertical, horizontal to horizontal, vertical to horizontal, and horizontal to vertical patterns. Those patterns are then plotted, and that is the radiation pattern envelope that you receive with every antenna that we provide. You know, just guessing or simulating, when you're trying to coordinate in a very tough situation, I'd like to see radiation patterns instead of a simulation, and you can expect that from CommScope. So real quick, our value line products. You know, value line are the antennas that can be standalone antennas or directly integrated to a radio. So the back of the dish on this antenna would allow any type of transmission line to be able to be fed from here, or have an interface plate and a radio OEM attached to this. We have interface plates or relationships with all of the major radio OEMs globally. So whether you want a standalone or a direct fit, we have antennas from 1 feet to 6 feet in diameter, 6 gigahertz all the way up to 80 gigahertz. We do have a small cell value line solution. It's a VHLP 200, and that's a 7-inch antenna that is available in 23, 24, 26, and 38 gigahertz. For TMW antennas, the unshielded antennas, those are the granddaddies. They have been the tried and true solution for long, low capacity, little interference type paths. They can be single or dual polarized, have very reasonable, good RPE patterns, and are available from 4 feet to 15 feet in diameter, from 900 megahertz all the way up to 13 gigahertz. The shielded or the high-performance antennas are available in single or dual polarized versions, starting at 4 feet to 15 feet in diameter, covering frequencies of 2 gigahertz all the way up to 15 gigahertz. Extreme line. Extreme line was a line of antennas that we developed years ago to accommodate some high wind application areas. In recent years, in taking a look at the hurricanes, the typhoons, I'm based in Chicago, and last year we had the worst winter that I can remember in the last 35 years. A lot of icing. Even now we're seeing areas that may not be weather-driven. Antennas that are going near mining, fracking, any type of corrosive environment can eat away at the reflector and at the mounting hardware. And it's regardless of which antenna vendor you have up there, that material is exposed to these elements. So we've designed a line of antennas to accommodate these extreme conditions. So we have a W-series antenna where it takes the traditional TMW antenna, which is rated for 125 miles an hour, and this high wind version brings it up to 155 miles per hour. If the antenna is not only in a high wind but also a corrosive environment, we strongly suggest applying a what we call a corrosive protection package, and that is where we place an epoxy paint on the reflector. We double galvanize and paint the hardware to help protect any of the critical attachment pieces from being eaten away by the corrosive environment. There's also a T-series. So let's say it's the antenna that you're deploying is not going to be in 155 mile per hour exposure, but perhaps somewhere in between. A T-style mount is a nice interim solution for 6-foot antennas to be able to bring them up to a heavy-duty wind survivability. Pressurization we talked about, for drying or deploying a elliptical waveguide. Elliptical waveguide is a hollow tube. That hollow tube, if moisture gets in, we all know, we hear that echo, we have experienced drop calls, we realize that moisture, regardless of how good an installation is, moisture is bound to creep into a microwave system. Whether it be a creep in from the attachment of the connectors or at the antenna feed, it's bound to happen. And so whether you spend thousands of dollars or even just $20, having some type of drying element to take out that moisture from your transmission line, your elliptical waveguide system, is highly recommended. And we have that full breadth of products available. All right? So let's go back to this slide. It discusses the challenges, the challenges that we all see. So what exactly have we done? I mentioned that we took a look at this passive antenna and we figured out a way how we can change the design and the performance of that antenna to help complement and address each one of these challenges. All right? So I promise you, this photo is not Photoshopped. This is an actual site. It's a beautiful site for a microwave person, but it really shows the impact that we're feeling out in the market. Now, if you were a carrier or an end user that were trying to coordinate space on this particular tower, you'd be pulling your hair out trying to figure out a way to get another link using this tower space. Microwave antennas in the past really didn't play a role because it is a passive component. But now with the new line, the new Sentinel line, we're able to help efficiently utilize the spectrum that's out there, along with the radio developments. Right? So Sentinel, its impact is by improving the amount of spectrum, you're reducing interference, and so you're able to increase your capacity, which means, for those of you who like to hear increased revenue, your throughput and revenue will be increased. You have clean spectrum. So what does that mean? You're not even interfering with yourself or others that are in that particular link. So more spectrum available, not only for today, but also any future expansion that you might have. And the cost savings. Tower owners have, through the years, increased the tower leasing costs. In the past, the rule of thumb is typically $100 per foot per antenna. So a 4-foot antenna will cost you roughly about $400 per month for that tower lease. You have 2 antennas, possibly 3 in your microwave link, and you're looking at anywhere between $800 to $1,200 just for that one path. Multiple paths, 40, 50, 60 links in your system, the ability to be able to go to a smaller antenna without giving performance, I'm sure would catch your attention. So basic wireless concept, when your channel bandwidth increases, you obviously have to increase your power, which results in an increase in noise in your link capacity. This is Shannon's equation. It's what we all live and breathe as microwave design engineers. So, in other words, let's say, let's think of it as there's 2 people. We're having a nice conversation in a bar, talking about last night's hockey game. And when we're talking one-on-one, the level of voice, or you might say our power, is pretty low. It's pretty calm. We can hear each other without raising our power or raising our voices. Now, it gets later in the day, and a few more people come in, and they're having their conversation. And you throw in a couple of TVs that might be turned on, maybe a jukebox, a couple of cell phones going off. There's a lot of outside noise, a lot of interference going on around the conversation you and I had. So what happens? The conversation you and I started out with at a very normal, low power kind of mode. Now all of a sudden we're raising our voices to the point where after a while we decide, you know what, I really don't want to continue raising my voice and screaming, so I just don't talk as much. So we either increase our power so that we keep up with the conversation, or we say, oh, forget it, and we pull back and just not have a conversation. And typically that's what's happening out in the microwave world. We want to make sure that the C over I, or the carrier power to interference ratio, is as high as it possibly can be. So what does that mean? We want to make sure that we reduce the interference, the I in this equation, as much as possible. So how do we do that? With a passive component, again, we're trying to control or affect an electrical parameter with a passive component. How is that possible? Through side lobes. 99% of the time, when you are coordinating a microwave antenna and you go to the regulators and you say, SRSP, I would like to put in a 6-foot microwave antenna in this particular link, and they'll come back and they'll say, oh, you really can't. There's a lot of interference. You need to go up to a larger dish, an 8, a 10, a 12-foot dish. Now, I can't tell you how many times that I've heard that when I was coordinating sites and just trying to figure out how am I going to find a spot for a 10-foot dish when I've already calculated a 6-foot dish. It causes you to toss and turn at night. So at CommScope, we took a look at how can we improve the performance by reducing the side lobe energy without giving up any of the gain. So on this slide, I talked a little bit earlier about radiation pattern envelopes. So the top line, or the red line, is the radiation pattern envelope for our Class 2, or the traditional TMW antennas. It's the antennas that everybody started out with, were tried and true for many years, and had very good gain, or very good main beam, and pretty high side lobe energy. As cellular communication increased, we then started seeing the drive in the market for better antennas. And so the Class 3 antennas, or our current value line type antennas, were developed. Again, Class 3, very good main beam, high energy, and then totally reduced the side lobe energy. Most manufacturers of microwave antennas manufacture to Class 3. Now, what does Class 3 mean? So ETSI, ETSI, is the European standard for frequency and spectrum coordination. They pretty much say what the performance and what the diameter of antennas should be at the various frequencies. They set the standard. And it's the other coordination arms in the world that kind of follow suit. So ETSI is pretty much the leader of standards. The FCC then kind of takes the ETSI standards and tweaks it a little bit, as does the Canadian SRSP and the South American Anatels, etc. So basically, ETSI takes a look not only at the main beam, but also the entire pattern. And it is those standards that most microwave antenna manufacturers try to meet. So Class 3 is what most antennas are. All of our value line antennas are. And we realized that Class 3, good performance, was able to take care of a lot of the market needs. Last few years, with the explosion of all of these smart devices and needing to stream faster and download faster, the use of spectrum and spectrum waste. I mean, if you take a look at some areas in the globe here, folks were just popping up microwave paths just to get service up so that they could start collecting revenue without really giving much focus on actual link planning. So there's a lot of spectrum waste. If we were trying to coordinate a 6 or 11 gig path in any of the major U.S. cities, it's almost impossible to find a path that's clear and open. In Canada, when we take a look at the major cities in Canada, even those areas, so the Montreals, the Ottawas, the Vancouvers, very, very crowded spectrum in the long distance or the 6, 11, 18 frequency bands. So with Sentinel, we developed the green line, the Class 4 antennas. Main beam frequencies still very strong, but we've totally reduced the side lobe energy. And it's that energy that allows for interference suppression. Now, I wish I could see all your faces because I'm thinking you're all saying, wow, that is incredible. It's by reducing that side lobe energy, it allows us to still have very good main beam energy without having the interference in the side lobes. So you're probably thinking, okay, that if that was so easy to do, why have antenna manufacturers not done it in the past? It's very difficult to reduce the side lobe energy and still maintain the main beam. We have done many case studies, a very large study in Hungary where the operator there asked us to take a look at their existing network and do a simulation of swapping out antennas that they had in place with the Sentinel or the Class 4 antennas and let them know what the improvement, not only in throughput, but also what the increased revenue would relate to. We just completed EE in London, did the same type of simulation. And just recently in LA, a carrier came to me and said, I'm trying to coordinate an 11 gig path in LA. It's almost impossible. So the red lines in the map are paths that have interference right now, today, as we speak. The performance is 2 nines or less, so near failure or dropped paths. The green lines are 3 nines or better of performance. So I took all of the information, all of the antennas that were deployed in this area, and I simulated taking those antennas out and popping in 3-foot 11 gig Sentinel antennas. Now there were a mix of antenna vendors, there was a mix of radio vendors, and so what we did is we normalized the overall output power on the radios, and we randomly assigned a channel to each link. Right? So it wasn't as if we were cooking the books trying to load it in our favor. Now, there were 91 links that we analyzed in 11 gig. After we simulated replacing those links with Sentinel, 59 links became interference-free. Right? So there was a 40% improvement. That allowed not only more paths to be coordinated, but it improved the efficiency of the paths that were there. So what does this mean to this particular carrier? They were able to go in and coordinate more paths at 3-foot, 11 gig, instead of having to go to a 6-foot or an 8-foot dish. without paying that higher leasing cost and deployment and transportation and all of the costs associated with larger antenna deployment. Sentinel also reduces the freight bill. I mean, obviously, to ship an antenna, a 2-foot or a 3-foot antenna is substantially less than shipping out a 4- or 6-foot antenna. And it's the savings on the tower leasing cost. Now, again, we're looking at $100 per foot per antenna. So deploying a 3-foot dish instead of a 6-foot, you have an immediate $300 per site savings on tower leasing costs. So Sentinel may not answer the interference or the congestion and the coordination issues in all cases. I challenge all of you, if you have a path or a site that is just keeping you up at night, you can't coordinate, or you're just having a lot of issues with a site at 611, 18, 23 gig, 38 gig, please let Boyd and his team at Alliance know. Give them the coordination, the PCNs, if you will, and we can work to see if Sentinel, if deployed, can alleviate any of the issues that you're having. And it's not just with Sentinel. You know, there are solutions available in traditional TMW antennas with waveguide, with flex twist, with pressurization that Boyd and the Alliance team are poised to help support. So with that, there are a series of white papers that we have available that really go into the details of these very large global carrier exercises that we've done. You know, the folks in the carriers that are on the line, we'd love to be able to take a look at one of your network layouts and see if we can help improve the throughput. Just from the Hungarian carrier that we helped analyze 4,000 paths, they were able to increase their revenue by over $4 million at the end of the first year, and that's because of the increase in data throughput. The London simulation, the white paper should be out at the end of November, and the numbers that we're looking at in savings for the carrier there makes the Hungarian numbers look very small. So again, a very exciting product portfolio. It's a little bit more technical, so it may not come up on your radar because it is a little bit more work to take a look at the benefits and justify deploying Sentinel. The typical ROI for a Sentinel antenna is less than 3 months, and everything after that just helps improve not only your coverage, your capacity, but more importantly, your throughput, which translates to more revenue. Again, full line of white papers available. Be more than happy to send you copies, which goes into depth of the analysis. We also have presented these at conferences, worldwide conferences, and face-to-face meetings with many of you. But again, if there are any folks on your team that you'd like us to bring in our team to help discuss the benefits of Sentinel, please let us know. With that, I wanted to make sure that I left about 15 minutes for any questions that might be out on the line. And I thank you for your participation and attendance today.
Thank you, Jackie. That was an excellent presentation. I think that it's obvious your passion for microwave antennas. We've had awesome attendance on the webinar. Everyone's with us. So I'd like to know if anyone out there has any questions. You can submit them via the chat or questions console. I know we had a few questions that people submitted on the registration. but I do think we covered quite a bit of that. One of the questions I thought was a good one, though, was discuss what changes we can expect in the design and implementation of microwave systems. You did kind of cover that.
Yeah, smaller, without giving up the performance. You know, it's communities, municipalities are making it so difficult for the carriers to be able to deploy microwave antennas. When you say microwave and people start freaking out like, oh my gosh, my children are going to glow in the dark if they walk past a microwave dish. And so, you know, trying to get an 8, a 10, a 12-foot dish up in some communities is almost impossible. A lot of the communities that I'm working with, they want smaller antennas so that they can hide it, whether it be on a rooftop or on a parapet, so that it doesn't look like this big honking microwave dish. Really difficult to do. And I think with Sentinel, because we have been able to maintain the performance yet reduce the footprint, is a very, very good solution in those situations.
So I do have a couple of questions that have come in. One question is the antenna smaller? If the antenna is smaller, will it need higher power RFU?
No. Sure. No, absolutely not. So the antenna is the passive, obviously, but because we've done some pretty remarkable changes to the feed, to the radome, to the reflector itself, that by changing these subcomponents, we are able to maintain the gain and dramatically reduce that side lobe energy. So let's say you have a radio with ACM. ACM and Sentinel is like a marriage made in heaven. It's amazing the amount of bandwidth and throughput that you can get through.
Okay, great. Here's another question. Have you got 4-foot and 6-foot 11 gigahertz dual pole antennas that interface directly with SAF radios?
We are working with SAF. As I mentioned, we have integration plates with just about every radio manufacturer. SAF is a new OEM to us that we're working very closely with. And I can give you kind of, I'll give the Alliance team a timeline of when we expect to see that completed.
Okay,
and
great.
they can pass that on to you.
Another question from the same person. In Southern Ontario, Industry Canada will only approve an 11 gigahertz license with a 6-foot antenna. Would these new Class 4 antennas allow us to use a smaller antenna?
We are working very closely with the Canadian SRSP to see if we can convince them that the gain, and again, it's all being driven by gain. Same thing with the FCC. They look at gain and diameter as opposed to the entire envelope. So we are working with those two particular regulators to get them to take a look at their standards and hopefully change them fairly quickly. We've done the same exercise in Spain and France, and two extremely difficult countries to get the regulators to change. And just recently they announced that any new sites going up have to have Class 4 antennas. So we're very optimistic that the Canadians and the FCC will take a look and start reducing the requirements.
Okay, great. Thank you, Jackie. I think that's all the questions we've had. Anything that we didn't quite answer, we will take offline. And you can always send an email to me, Lisa at Alliance, or anyone else at Alliance that you know. I think that concludes our webinar, unless you want to add something else, Jackie?
No, thank you again for everyone joining in. And again, we have not only white papers that we can help answer any of your more detailed questions. For any installers that are out there, if you have new employees that you may have some downtime where you'd like to kind of bring them up to speed on an overall overview of microwave and microwave technology. We have an online training course called MAST, M-A-A-S-T. MAST is a 9-module training course. The first 2 modules are pretty tough. It kind of goes through microwave theory and RF concepts. And then the other 7 modules really dive into antenna alignment, antenna choices, steel and steel structures, and mounting. And some of the modules have testing at the end. And we have a wall of fame, if you will, that you know, when you take the quizzes and pass, you can post your name onto this wall of fame that shows that you are a MAST graduate. So it's a really great module. To start to finish all 9 modules, if you turn off your phones and kind of lock yourself up in a quiet room, you might be able to get it done in about 3 to 4 hours. But each module you can take at your leisure, stop it, pause it, come back to it. And it's a really nice training course for those that are either new to microwave, or it's a nice little brush up, you know, for those seasoned veterans. We sometimes get comfortable, and this is a really nice refresher course for us veterans.
That sounds great. I think, you know, what I will do is I will send out a link to where you can find more information on the training and on the white papers as a follow-up to the webinar. So if anyone wants to just, you know, you can just link straight from the email. I'll be sending out an email probably by tomorrow. So everyone, thank you very much again for joining us. Keep an eye on your email for future webinars. And thank you very much again, Jackie and Ray, for presenting today. I really appreciated us here at Alliance. It's a great, it's an excellent, valuable tool for everybody to have this in the future. We have made a recording of this, and we'll be sending out a link to that as well. Have a great day.
Thank you.